In today's lesson, we'll be investigating properties of similar triangles. I have two congruent triangles. Let's label each of their vertices. In congruent triangles, both corresponding angles and corresponding sides are equal. Let's represent this mathematically. I would say angle ABC is equal to angle DEF. Next, I would say angle BCA is equal to angle EFD. And last but not least, I would say angle CAB is equal to angle FDE. In terms of side lengths, I would say side length AB is equal to side length of DE. Side length of BC is equal to side length of EF. And side length of CA is equal to side length of FD. We have two similar triangles. Let's label their vertices. In similar triangles, corresponding angles are equal, however, corresponding sides are not equal. The ratio of corresponding sides are equal. Let's represent this mathematically. So I can say angle ABC is equal to angle DEF. And I could say angle BCA is equal to angle EFD. And I can say angle CAB is equal to angle FDE. In terms of sides, the ratio of corresponding sides are equal. So let's represent this mathematically. So I'm going to say AB over side length DE is equal to side length BC over side length of EF, and that is also equal to the side length of AC over the side length of DF. So as you can see, the ratio of corresponding sides are equal. In summary, for congruent triangles, corresponding angles are equal, corresponding sides are equal, and to represent this mathematically, you would say triangle ABC is congruent to triangle DEF, and you would use an equal sign with a tilde symbol over top. For similar triangles, corresponding angles are also equal. However, ratios of corresponding sides are equal. And mathematically, you would say triangle ABC is similar to triangle DEF, and you would be using this tilde symbol all by itself. In our first example, we want to name a pair of similar triangles in each diagram and explain why they are similar. As you can see, we have two triangles in this diagram. We need to prove that they are similar or not similar. To do that, you either have to prove that the corresponding angles are equal or that the ratio of corresponding sides are equal. But since we do not have any side lengths, that means we're going to have to use their angles. So first, let's organize ourselves. I'm going to first start with angle or triangle RST, I should say. And I am also going to write down the other triangle. So the other triangle would be RPQ. Immediately, I can see that these two angles are equal, and they're equal because they are opposite angles. So let's write that down. Angle SRT is equal to angle PRQ. And the reason for that is that they are opposite angles. It's important that you write the reason down. There's proper notation for this, which you will learn later. Next, I can see that angles RST and angles PQR are also equal, and they're equal because they're alternate interior angles. You might have referred to this as the Z pattern previously, so let's write that down. Angle RST is equal to angle PQR, and that is because of the alternate interior angle. Otherwise known as the Z pattern. And last but not least, you can see that angles RPQ and angles RTS are also equal for the same reason. So let's write that down. Angle RPQ is equal to angle RTS for the exact same reason. The Z pattern. Since we've established that corresponding angles of these two triangles are equal, therefore you can conclude that they are similar triangles. Therefore, I'm going to say triangle RST is similar to triangle RPQ. In our second example, we want to name a pair of similar triangles in each diagram and explain why they are similar. Remember, when you're trying to prove that triangles are similar or not, you either need to prove that corresponding angles are equal or the ratio of corresponding sides are equal. Since there are no angles listed in these two diagrams, therefore we're going to have to use corresponding sides. We're going to begin by listing out our ratios of corresponding sides. AC corresponds to side DF. Side AB corresponds to side DE, and side CB corresponds to side FE. You'll notice that I've kept the side lengths of the smaller triangle all in the numerator and the side lengths of the bigger triangle all in the denominator, just to make sure you are consistent. It doesn't matter if you switch these around. Start substituting in our numbers. So I have 1.8 over 5.4. Here I have 3.0 over 9.0. And over here I have 2.5 over 7.5. If you simplify this into a fraction, you should get 1 over 3. So as you can see, the ratio of corresponding sides are all equal. Therefore, we can conclude that these two triangles are similar. So let's go ahead and write a concluding statement. I'm going to say, therefore, triangle ABC is similar to triangle DEF.